Are we on? Hi. Hello, everyone. You're here to hear about Guava. If you're not here to hear about Guava, please stay anyway and listen to us talk about Guava. My name is Kevin Berillion.
And I'm Alfred Kluever.
And looks like we can get started. What is Guava? Guava is a suite of the common utility libraries that we have found the most useful at Google across all of our thousands of Java projects that we have at Google. So we are talking about collections, concurrency, utilities for working with primitives, reflection, etc., etc. We have found that no matter what kind of application we're building, whether it's server-side, whether it's in the browser, using GWT or on a phone, these kinds of things tend to be needed again and again. And so the way we think about it is the things that you might have expected to find in the JDK, but one more level above that, the JDK plus, however many pluses you want to give it. And it's released to you under Apache 2.0 license. Why do we do this? Guava's goal is pretty clear. We want you to write less code. We want you to accomplish the same things and have less code to write to do it. But also, we want to make sure that the code that you do write is as simple and clean and readable as it can be. So if your utility libraries that you're using don't have the exact right behavior and you have to work around them, it makes your code harder to understand. If your utility libraries have not very well named classes and methods, then when you read your code, you're going to be calling not very well named classes and methods. It makes your code harder to understand. So our goal here is really not about our code, it's about what can we do for your code to make your code the best it can be. We are on release 12.0 right now. In fact, we just put out a release candidate for that this week, and we hope to go final with it very soon. We release every 3 months. Pretty much like clockwork, more or less. It's train leaves the station kind of a situation. But we try to make sure there is significant new functionality in each release, and anywhere from 30 to 40 to 50 issues fixed, kind of. What is a little bit different about Guava from most libraries is that we have a mixture of APIs that are marked as being API frozen and those that are not API frozen. We mark the non-frozen APIs with an annotation called @beta. All that means is that it's still subject to change. But because of this, it means that in every release that we make, every 3 months, we always have to keep bumping the major version number. That's why we're already at 12.0, even though we've only been doing this for about 3 years. Because any of those beta APIs might have changed incompatibly, so it constitutes a new major version. And occasionally we also need patch releases, so our last version was 11.0.2. What we're here to do today is give you just a very incomplete overview of some of our favorite libraries in Guava. There will be some rhyme or reason to the choices, but it'll be somewhat random as well. And we would love to get as many of your questions as we can get in as well. If you have a question that really relates to the slide we're on, if there's a question that would help you understand the slide we're on better, that means that your question would also help half of the people in the room understand that slide better as well. So please raise your hands as conspicuously as you can. Whoever's not talking at the time will be trying to watch for that. We can answer that right away. If your question it just seems related to the slide, probably better asked at the end. And also, if you're more comfortable asking your question in French, we will bring our teammate Charles to the stage and he will field the French language questions. That would be fine. And with that.
Okay, so that was a brief overview of the project. Now we're actually going to delve into some of the specific APIs that we provide in the library. We'll start off with the stuff that's in common base, which is very low-level stuff, and we'll build up from there. The first API we'll present is preconditions. These are used for validating assumptions that you have right when you enter a code block. So whether it's right in a constructor or it's right at the top of a method, these are assumptions that you make about either the parameters you're getting or the state of your class. and you need to assert these, and you want to throw an unchecked exception if they do not hold. So in this instance, we're going to demonstrate three different methods on the preconditions class. I've statically imported these here. Since we tend to use these very, very frequently and in almost all classes, we recommend that people statically import them. So the check not null is actually preconditions.check not null. So it's a static method on preconditions. Similarly with check argument and check state. So check not null, you pass it a reference to an object. If it's null, it simply throws a null pointer exception. This is really useful in constructors because typically if you didn't check not null the incoming parameters in your constructor, later on you might try to call a method on the engine and you'll blow up then. So it's really better to fail fast in this situation. So here we check not null the engine to make sure that the car does indeed have an engine and not a null reference. Later on we have a method called drive. We want to assert a few things before we actually try to drive the car. The first thing we want to assert is that the speed is actually a positive speed, because it doesn't make sense to have a negative speed. So here we actually are using, there's a string substitution that you can use, so you can actually, in your debugging output, in the illegal argument exception, we'll get the contents of this string. So we'll actually substitute the speed in if this precondition doesn't hold. Second, we check that the engine is actually running because you can't drive a car unless the engine is running. So we also use this check state. The check state will throw an illegal state exception if the engine.is running returns false. Moving on, this is a completely separate API, but this is something that makes implementing object.toString a lot easier. So instead of using a bunch of string concatenations or a string builder to build up your toString return value, this objects.toString helper makes it a lot easier. So basically invoke it like this. You keep adding on all the different primitive types or other objects that you have as the fields in your class, and then you just call toString on it. In this instance, the pet name string field in this class is actually nullable. So if you use the omit null values option on the toString helper, then it won't print that field in the output. If you don't have that option on, then it will actually just print pet equals null. It depends on how you want to format the output for your toString. Stopwatch. This is preferable to use over system.nanotime or system.current milliseconds. Instead of having to do the subtraction yourself and keep state in a local, long variable, what you can do is you create a stopwatch instance, and then you can start the stopwatch and later stop the stopwatch when you're done with whatever operation you're trying to time. So in this instance, we're doing some other operations. This could be some long operation that you want to time, and maybe watch how long this operation usually takes. When you're done, you can just call stopwatch.elapse millis. The stopwatch will continue to run at that point, but if you'd like to explicitly stop it, you can also call stopwatch.stop. If you want to get it in some other format, like nanoseconds or minutes or whatever time unit you want, you can also get that from this API as well. It's also important to note that this measures relative timing, so it's not absolute timings like system.current time millis or system.nanotime. So this is just elapsed time from when you started the stopwatch till when you stop the stopwatch. Okay, string splitting quiz. Can anyone tell me what that split statement at the top will do? Who thinks it's A? A few. B? And a few. C? D? Okay, so majority said D. It's actually A. The semantics of string.split are pretty ill-defined, and it's obviously complicated to know without testing. But what we probably want is actually B, because assume this input comes from some user who's typing in a field, and you asked them for a comma, separated list of inputs. So probably what we want is we want to only get the different inputs there with the delimiters stripped out. So to do this with string.split, as we saw, it's not easy. So we have this class called a splitter. The splitter, you define what your delimiter is. In this case, we're using a comma. And then there's other options you can add to this splitter class, the splitter instance, to split as you desire. So like I said, it's basically a more intuitive string.split. It doesn't silently discard the trailing separators as string.split did. And it handles empty pieces predictably, meaning that it gives you options to either omit them or trim the individual pieces. So in the previous slide, here we're going to trim the results, so that's going to trim off any white space from each piece that we've done. And we're also going to omit empty strings, so we don't want an empty string in the results. So this class gives you a lot of configurability for splitting strings, which is useful for user input. So similarly to string splitting, we also have string joining. Joiner is basically does the opposite. It concatenates a bunch of different strings using a delimiter. If any of the strings that you're passing in happen to be null, we'll throw a null pointer exception, unless you specify one of these two options. Either skip nulls, which does exactly what it says, it'll just skip right past the null inputs, or you can use for null, and that you can substitute in another string literal, like you could substitute in the string unknown. So in this case, we're going to join on a comma space, and we're going to skip any nulls, and then when we call joiner.join, we pass several different string inputs, and we'll actually yield pretty much exactly what we want for our output. This really helps if you're ever joining strings into, for user visible output, so you don't have to have, is a Boolean, is this the first piece in the string to join? A char matcher. This is basically breaks down into two steps. The first step is you have to define what is a matching character. So we've defined a bunch of predefined ones like white space, ASCII, any, which matches any character, etc., digit. And these are static constants on the char matcher class. Or if you want, you can define your own. So if you want to say, is this the X character, or is this not the X character? Or you can say, is this one of any of these characters in this string? Or you can use ranges as well. Or if you like, you can also subclass char matcher and implement matches directly. So once you define what characters this char matcher will match, you have to say what to do with these, what to do with the char matcher then. So there's a whole list of different options here. I'm not going to go through them all, but you can basically either ask Boolean queries, like does it match anything, or you can get a numeric answer back for the index. You can also remove, trim, and collapse from these char matchers from your inputs. So for example, to scrub a user ID, let's say the user ID is only digits and dashes. We can use char matcher.digit, so that will match all digits. You can actually join these char matchers together using or. So we say it's a digit or it's a dash, and then we retain that from the user input. So if the user typed in other characters, the result will actually only be digits or dashes. Okay, optional. This is an immutable wrapper that either is in two states. It's either present, which means it contains a non-null reference, or it's absent, and it never contains null. So an absent optional contains nothing. It doesn't contain a null reference. Possible uses for the optional class as a return type. So instead of returning null or a nullable foo, you can return an optional foo. Then people won't, if they try to dereference whatever they get back from the method, they won't null pointer out right away. They'll have the option of seeing if that optional is present or not. You can also use it for other things, like if you'd like to store instances in a collection that doesn't support null values. Like any of our immutable collections, they don't support null values, so you could wrap them in an optional. So yeah, let's see. There's a few different ways to create an optional. You can either do optional.of, and that requires that your reference that you're passing it is non-null. You can also do optional.absent, that explicitly says this is an absent optional. There's, and then optional.fromNullable. FromNullable actually will take a nullable reference. If you pass it a nullable reference, it'll return you optional.absent. If you pass it a non-null reference, it'll return you optional.of. So once you have this optional of t, to unwrap it, you have a few different options as well. If you call get on it, it'll return you the contained instance. If that optional was actually optional.absent, it will throw an illegal state exception. You can also use this to do easy defaults. So if you have an optional, you can say optional.or a default value. This is useful. So
If the optional isn't present, if it's an absent optional, you can just pass an OR, which is a default value. In this case, we're defaulting to UTF-8. Or if the default value that you want to return from that is expensive to compute or to load or whatever, you can pass it a supplier directly. So you can say your optional.or and then give it a supplier that will lazily load the default value. Or if you just want to get null back from this, if the value isn't present, then you can use or null. A few other useful methods on optional itself. As set, this is basically a shortcut to turn your optional into an iterable. It actually returns a set, but it's sometimes useful to have an optional that's an iterable. The iterable will either have 0 or 1 elements in it. Either if it's absent, it will have 0. If it's present, it will have 1. And finally, optional.transform. Transform takes a function, which we'll get into right after this, and basically a function just transforms one type into another. So a function is from f to t. This is a one-way transformation. It takes type f and transforms it into type t. And all you do is override one method, this apply method. The most common use for this is transforming collections into a view of that other collection. This kind of goes into a little bit of functional programming with Java, which is currently kind of messy, but it does have its the right, when used rightly, it can make your code cleaner. A predicate is similar to a function in that it's still functional programming-ish, but this only determines true or false for a given input. So here you override the apply method, and you basically tell whether or not the reference that you pass to it applies or not. And the most common use for this is for filtering collections. If you want to say, give me all the items in this collection that are, men, or something like that. So now we're going to jump up one level into Common Collect. This is basically all the collection-related stuff that we have in Guava. This is just a brief overview of what's in there. Okay, so this is our functional programming example. Here we're defining a predicate, and this predicate is going to be on clients. And again, we're overriding the apply method. And here we're going to determine this predicate is going to match clients that have been active in the past month. And we're also introducing here Fluent Iterable, which is new in our Guava 12 release. This lets you do basically chaining of all these different options here on an iterable, and it makes it very clean to read. So here we're going to do fluentiterable.from. We're going to grab the entire client list from the database. We're going to filter out all the filter out all the inactive clients, so we're left with just the active clients. Then we're going to transform this collection, or this iterable rather, using the toString function. So we're going to take all those client objects and call toString on them, and then we're going to limit it to 10, and then bring this into a mutable list. So in this nice little 5 lines we've got here, we've queried the database, filtered out inactive clients, transformed them so we're just getting the name of the client, pulled out the top 10, and gotten it into an immutable list. I'll go into this is pretty much most of the Fluent Iterable API here. So there's a few different ways you can use Fluent Iterable. You can either use it for chaining, which there's a few methods you can use for chaining them. These will return another instance of a Fluent Iterable that you can keep working with. So skip, you can tell it to skip over the first 10 elements or the first n elements of your iterable. This will again return a Fluent Iterable with those first elements skipped. Limit, you can say only give me the first 5 elements in this iterable or 10 or whatever you have. Cycle will basically keep cycling the iterable indefinitely. So this, you can use this however you want. And then filter and transform, which we saw before. These will take a predicate and a function. For querying the Fluent Iterable, these return booleans. All match or any match, these will take predicates and say, do all the elements in this Fluent Iterable match this predicate, or do any of the elements in this iterable match the predicate? Contains is, we'll take an E, and that's very simple. Does this iterable or not contain this element or not? Whether or not the Fluent Iterable is empty. Converting, as we saw in the last slide, you can also convert these. Once you have a Fluent Iterable, you can convert it to a immutable list, immutable set, or immutable sorted set. Or you can just dump it out to an array if you'd like. And then for extracting from the Fluent Iterable, you can also say, give me the first element in the Fluent Iterable, the last element in the Fluent Iterable, or the first matching element in the Fluent Iterable with a predicate. These 3 methods will actually return an optional. So if your fluent iterable is empty and you call first, you'll get an optional absent, an absent optional. Similarly with last and first match. And get just returns the whatever element given an index. Okay, so we just saw some ways that functional programming is actually useful, but you do have to be careful with it. Here we've used both a function and a predicate to use this example, and then we'll actually show what it would look like if you didn't use functional programming. So all of this, if you do it just the normal way, actually is much shorter. So you have to use functional programming with care. We've seen a lot of people do this at Google, unfortunately, and if you use functional programming for everything, it actually turns into quite a mess. So just use it, sparingly. All right, so also in Common Collect, we've got a few other interesting data structures that are not in the JDK. A multi-set, which is often called a bag, allows you to add multiple instances of a given element, and then it basically counts how many instances of that element exist. So it's kind of similar to a map from E to an int, but it's slightly different. There's only ever positive counts, so there's never, you can't have a negative count, which makes sense. When you call size on the multi-set, it returns a total number of items, not the number of keys, which is if you were to use a map from E to int, you would get the number of keys. And the iterator will actually go over each element in the multi-set. So, if you've got 10 of the string foo in there, you'll get foo 10 times in the iterator. And if you need something that supports more than just integer.max value for your counts, we have atomic long map. This is very similar, but it uses atomic longs instead of ints. Multi-map. This is sort of similar to a map in that it keeps key value pairs, but these key value pairs, there might be duplicates. So the values can that relate the map to a single key can be either viewed as a set or a list. And again, this is sort of similar to a map from K to a collection of V, but get never returns null. So if you call get on this multi-map, you'll never get null. You'll only get the empty collection back. Contain key is true if there's one or more values. And again, size will return, similar to the multi-set, the total number of entries, not the number of keys. And if you want to just view this multi-map as a map from K to collection V, you can do that as well with the as map view. Bimap, this is basically a bidirectional map. This makes sure that both your keys and your values are unique. So it's an invertible map as well. So if you'd like to invert the map, there's the inverse method that will give you basically the same exact, just the inverse of the map that you have. You can mimic this by having two separate maps, but maintaining those is a pain. So if your values are also unique, then you can use a bimap, which maps unique keys to unique values. And finally, table. This is basically a two-tiered map, or you can think of it a map with two keys. So you can think of it very similar to a table where you have a row and a column, and these tables can either be sparse or dense. So a hash-based table is going to be backed by two hash maps, which will be a sparse table, and a tree-based table will be backed with two tree maps, which will be also sparse. However, if your data is densely packed, like let's say you're using ints and you have ints and ints for your two keys, you can use an array table. This is backed by an actual array of whatever object type you have. So this will be much more densely packed. But if you have a non-dense data, then this will use a lot of memory. Additionally, you can get many views from this underlying data. You can view them as column maps, row maps, column sets, row sets, or if you want, you can just view all of the entries as a set. So you can get, we've defined a new entry class that takes, that's three elements, the row, the column, and the value. And you can get a set of all those back. And you would typically use this where instead of, in your code you might see a map from R to a map from C to V. You can use this instead. Basically when you have two keys that you want to look up a single value with. And immutable collections. I touched on these briefly before, but we offer an immutable flavor of every Java collection in the JDK as well as the ones that we just saw that we've added in Guava. the benefit of immutable collections is that they're inherently thread safe. So if they're immutable, then you don't have to worry about thread safety at all. They've also have reduced memory footprint and slightly increased performance. We've worked hard to make sure that these stay performant. And you would say, why would we provide these if collections.unmodifiable also already exists in the JDK? The collections.unmodifiable actually is just a view of the underlying data. So if anyone maintains a reference to that data structure that you've passed into that, they can change what's inside of your unmodifiable collection. So immutable collections actually perform a copy, and they copy all the data into their data structure. They're also more efficient typically than the unmodifiable collections. And finally, the types convey immutability. So instead of storing these as a list of foo, we actually use mutable list as the type. So even though it's not an interface, think of it as an interface. That is, immutability is right there in the interface name. I'm going to pass this off to Kevin now.
Yeah. Question in the front. Mm-hmm. It's a shallow copy. Yeah. So your elements don't have to be clonable or anything like that. Okay. Yeah, the question is whether doing it a copy of an immutable collection is deep or shallow. The answer is it's shallow. So I don't know about you, but my favorite thing in Java is implementing comparators. And if I could write my project by just chaining together the right 340 comparators, that would be awesome. I mean, how many of you just love writing code like this? I hear the microphone system loves it. So this is fairly tedious, and as we'll see, it's actually fairly bug prone. We offer a couple of libraries to help you rewrite this. One of them is called comparison chain. So you're still going to implement comparator or comparable, but you have a very easy way to provide your comparison logic in a single statement. You simply say, the first thing I want to do is get the offset for each of them and compare them. And notice here, let me go back to the previous slide. Right here, who can tell whether this is doing a normal comparison or a reverse comparison? When I say int result equals offset 2 minus offset 1. Who looks at that and immediately thinks that's a reverse comparison? I know when I look at it, I stop and I think, if this one's 1, and it takes me a minute. Here, using comparison chain, you can simply see that I've passed in tzid 2 first and tzid 1 second, so I'm doing a reverse comparison, which is good because the variable is named by reverse offset, then name. In the comparison chain, as soon as it gets a value that is a positive or negative result, meaning it can decide which one is greater or lesser, it actually short circuits the rest of the computation. This comparison of the time zone IDs won't actually happen due to some magic in the implementation. So if the time zone IDs are tied, though, then it continues on to compare by the time zone IDs. We keep getting a lot of feedback on this mic. I don't know if there's anything we can do about that. So the comparison chain also, it has overloads to compare all the primitive types, like ints and longs and doubles. And it also has methods for comparing booleans, so you can call compare false first or compare true first. And also, if you want to compare objects with a specific comparator, you can pass that in as well. So, it's short-circuiting. It never actually has to allocate any instances, and it turns out to be pretty fast for those reasons. Yeah, question. The question is whether it uses a thread local. It doesn't do anything like that. I even described it as magic, but it's not actually even magic. When you look at the code, it turns out to be very simple. So I'll just let people go and look up that code online if they want to see how it really works. Here's another way that you can do it, and which way is better depends on the situation. You can also construct your comparator without actually having to implement comparator at all. Do it sort of declaratively using the ordering class. So what we're going to do is we're going to start off with a natural ordering then we're going to reverse it. Then we're going to say, apply that reverse natural ordering to the result of this function. And then if that ties, we will continue on with the compound method to then use natural ordering. And I didn't actually run the unit tests on this slide, so I might have actually messed that up a little bit. But imagine that it does the exact same thing as this, because it should. What you see here is, this is no shorter than the other slide was because we have to write out this entire function, but hopefully when we get our lambda expressions in JDK 8, this will become actually quite pleasant. Again, in this example, I would probably go with the comparison chain instead of the ordering, but you're going to find cases where one is more useful than the other. I think this slide is still probably not completely self-explanatory, so I'm going to go into a little bit more depth about what ordering really is. So ordering is a class that implements comparator. So once you have an ordering, you can use it anywhere that you would use a comparator. And it's very similar to that fluent iterable that we showed you earlier. You could think of this as being fluent comparator. Hold on. All right, common ways to get one of these orderings. To start with, you can just start with the natural ordering, or you could implement it yourself, just like we implement comparator, just simply implement ordering instead. If you happen to already have a comparator instance sitting around, then you can use ordering.from to turn that into an ordering. You don't really ever need to say ordering.from new comparator and then implement the comparator. There's no reason to do that because you can simply extend ordering in the first place. And there are a few other ways to create an ordering. This is an explicit ordering. It says, look, I'm going to tell you exactly what order these strings should appear in, and then you name the exact set of strings that you're going to be able to sort in what order they appear in. This actually comes in useful sometimes. Once you have an ordering, then you can use the chaining methods to chain it into an altered version of that ordering. So if you call reverse on the ordering, now you've magically got a comparator that compares things in the opposite order. You could compound it with another comparator. Again, that means use the first comparator as long as it tells you which one is less or greater. But if they turn out to be tied, that neither one is lesser and neither one's greater, then go on to try the next comparator. We already saw the onResultOf function. You can also say nulls first. That means you write a comparator that doesn't know how to deal with null, then you call .nulls first on it. Now you've magically got a comparator that's going to sort all null elements to the beginning of a collection and all the non-null ones as usual after that. And I won't go into lexicographical. It's kind of complex compared to the others. And so now that you've created an ordering and you've called these chaining methods, you can use that wherever you need a comparator, or you could use any of these really handy operations that we put right there on ordering for you. So for example, you could take a copy, a sorted copy of an iterable. You could ask whether an iterable is already sorted. You could find the min or the max, or you could even say, I want to know not just the one least element, but the 10 least elements in this entire iterable, with least of and greatest of. Okay. Again, ordering is better sometimes, comparison chain is better sometimes, but we strongly feel that either one of them beats implementing the comparator by yourself. Who in the room believes that they can name the 3 mathematical properties that every comparator implementation must have? Show of hands? All right, sir, can you shout them out? Reflexive, transitive, and symmetric. So close. That is the requirements for the equals method. Comparator has to be reflexive, transitive, and anti-symmetric. And I forgot what anti-symmetric means, and I was a math major. I had to go back and look it up in my old math textbooks. So it's actually, when you implement these comparators by hand, it is surprisingly easy to make very subtle mistakes that cause your comparator to not function correctly. And the worst thing is, it may function correctly for now, but when you upgrade your JDK and they change the sort algorithm, that might be the thing that suddenly exposes the bug. As long as you stick to comparison chain and the ordering methods, you basically can't go wrong. You're basically guaranteed to get a comparator that will behave correctly according to the comparator specification. It might not sort things the way you wanted them sorted because you might have put the methods in the wrong order or whatever, but you will get a basically valid comparator. The only exception to that is if you were to use on result of and pass it a very badly behaved function that returned a random value on every call or something like that. So now we're going to go into a little bit more detail on our new hashing API. Why would we need a new hashing API? Doesn't Java have object.hashcode? That sounds like a hashing API to me. I don't know about you. What could be wrong with that? Well, the way to think of object.hashcode is it is the hash code generating method that is good enough for in-memory hash maps. That is why it exists. It exists so that you can have your hash maps and your hash sets. And if you have a hash map where the hash function has a lot of collisions, where it sends the same keys or different keys to the same hash code, and those collide in the hash map, they have to go into the same bucket in the hash map. In general, overall, that's not actually too catastrophic. The code will completely continue to work correctly, and the performance drawback of having those collisions is not, when I measured it, is not actually as great as you might worry that it is. So object hash code needs to be just sort of good enough for that. But it is completely limited to 32 bits. You cannot have your 64-bit and 512-bit hashing algorithms in there. And there isn't even an elegant way to create a composed hash code where this hash code is based on that hash code, which is based on that one, and then just only limit it down to 32 bits at the end. Instead, you have these methods invoking object.hashcode in perhaps a big tree of objects, and it's continually limited down to 32 bits. So you're losing information. You're losing the hashiness of the hash function to some degree, if you will. A bigger problem to me is there's no pluggability at all. There's no separation between what data am I hashing and in which order am I hashing it versus which algorithm do I wish to use to hash this data. So if you were using MD5 and then you want to do something else, you may have to change a lot of code. Finally, implementations of object.hashcode tend very strongly to have very poor bit dispersion. What that means is that ideally, when you have a hash code consisting of 101100, these 32 bits, you want to be able to select out any subset of those bits, and you want to have only the expected increase in collisions. So if I take only the rightmost 3 bits of a hash code, I would like 1/8 of all elements to produce the value 0, 1/8 of them to be 1, 1/8 of them to be 2, and so forth. But if you have a weak hash function, depending on which bits are selected, you will get more collisions than you expect. And that turns out to be okay for hash code, for hashmap. And hashmap tries to correct for this by applying a secondary hash function to all of the hash codes that you implement. But sometimes you need to do better. Sometimes you need cryptographic hashing, or you want a reliable fingerprint for a document. You have a case where, okay, if this fingerprint collides, it's actually bad. There are other applications like cuckoo hashing and something I'm going to show you in a minute called BloomFilters. And none of these things, object.hashcode won't work for any of these things. I think we're okay-ish on time. So to address this, the JDK introduced an interface. Actually, they introduced 2 interfaces, because what's twice as good as one interface to do something? 2. There's both message digest and there's Java util zip checksum. And these are each named not after, there's no fundamental difference between these. They're simply named after different use cases for why you might be using it. But they fundamentally are trying to be the same thing. And the worst part is that they're not even any fun to use at all, unless you happen to be hashing a raw byte array. If you actually have a bunch of longs, you're going to have to convert those all to byte arrays and concatenate them manually, or at least pass them in one by one. We designed an API to be a little bit more friendly to use than that. So here's what our API looks like. First of all, you get the hash function you want. So in this case, we're using Murmur3, the 128-bit version. You start a hasher, and then you just start pushing all the data into it that you want to hash. And of course, the order that you push this data in matters. If you change this code to hash the data in a different order, you'll get a different result. And we support, all of the primitive types and strings. You can also pass a char set or a char set to put string, if you want to character encode the data while you're hashing it. You don't always want to do that. I would say you usually don't need to do that. And you can even hash any object type you want if you provide a funnel, which is a specification of how to slurp the data out of that object into the hash stream. And at the end, you just call hash. And now you have a hash code instance that you can do anything you want with. You can use it as you can return it from an API, use it as a key in a map, or you can get a long or an int, or you can get it as a byte array, etc. And it has a nice toString method that just prints it out as a hex number, because that's how we usually tend to view hash codes in console output. So as I mentioned, we have this unified API for all hash functions. And we provide implementations of the Murmur3 algorithm, which is a very well-liked hashing algorithm. We are not really hashing experts ourselves, but we have asked the people who are, and there's a lot of respect for Murmur3. We have 2 versions of it, and they are seedable. So if you have a reason to need different ones, just create different ones that are seeded differently, and they will be completely independent hash functions. We also give adapters for MD5 and SHA-512 and so forth, so that if you don't want to have to write your code to the message digest API sometimes and our API sometimes, you can just use our API all the time. And we also have this method called good fast hash. And what that means is, I don't care which algorithm you give me, I just want one that's going to be good and fast. So you would not want to use this if you are going to be persisting those hash codes and reading them again at some later date, because we may change good fast hash at any time that we want to. And some general also utilities provided in this API. Let me just tell you about one cool application for hashing. How many people in the room understand what a BloomFilter is and what a BloomFilter does? Okay, I had not heard of these things a few years ago. They are an almost magical data structure. It is a probabilistic set. What that means, you can ask it for containment. You can say, does this set contain this element? But what you get is a probabilistic answer. The method is called might contain. And a true result means, I probably have that element. And a false result means I definitely don't have that element. And if you're wondering why you would ever want a probabilistic set, sometimes you have more elements in this thing than would ever fit in memory. But the BloomFilter representation in memory is very compact compared to a giant hash set. The use case that I like to use for BloomFilters to help you understand why you would ever use one, think about a spell checker. If you type in a word like syzygy and it highlights it as being wrong, that is kind of annoying, because syzygy is a correct spelling of a correct word in the English language, unless I just typed it wrong on the slide. But actually I didn't, because the spell checker worked. But if yarzku, which is obviously not a word in any language that I'm familiar with, if that doesn't get flagged as an invalid word, that's not actually so bad, because almost certainly no one's ever going to type that. So you're actually going to be okay with a probabilistic check for a spell checker. And the one other use, which is really much more common, is simply as an optimization. So if you have, let's say that you have a very expensive Boolean query. It's going to return true or false, but it's going to take a really long time to do it, or consume a lot of resources just to come up with this true or false value. If it's possible for you to enumerate all the values for which that query should return true, you can create a BloomFilter, go through all those values for which it should return true, put them all into the BloomFilter, serialize that thing onto disk. And now, when your real production service starts up, it just deserializes the BloomFilter, and now, when you need to run this probabilistic query, check the BloomFilter first. And it will give you this probabilistic answer. If it says definitely not true, you're okay. In the small percentage of cases where it says, well, it's probably there, then you fall back on the full expensive query. And when you create a BloomFilter, you get to specify what false positive probability you're willing to accept. So a common value might be 3%. I'm okay if you give a false answer 3% of the time. That means you've just cut all the times that you need to do this expensive query down by a factor of 33. I think it's magical myself. I love these things. We have a package of caching utilities. It contains a powerful on-heap cache. We're not trying to compete with EH-cache or Memcache or anything like that. We're not trying to compete with JSR 107. But sometimes you need a cache that's just one cut above a map. You basically just want it to be on the heap in memory, and you want it to have some features. We actually have a ton of very useful features in here, but I'm not going to talk about them because Charles is going to talk about them in the next session after this. So if you feel like this session has been just too shallow of an overview over all these different topics, we can get into some real interesting detail with Charles after this. That's in Ella Fitzgerald. Okay, and all right, good timing. So here's a slide telling you how you should contact us if you start to use Guava and you need to contact anyone, which we hope that you will. If you need help with anything, if you have any specific problem, how many of you already are well accustomed to posting to Stack Overflow when you need help? Okay, good. I hope when I come back and ask that question next year, everyone will raise their hand. It is a fantastically useful site. And every time that, virtually every time that a Guava user posts a question there, they get an answer really quickly and a good answer. And sometimes they email questions directly to me and then they have to wait 3 days until I get around to responding to it. So Stack Overflow is a great way to get help. If you really are pretty sure you've found a defect or you want to request an enhancement, that's our URL for reporting one of those. I don't actually expect anybody to be furiously scribbling that down, but you can find it pretty easily from our main project page. And we also have a mailing list, which is sort of the catch-all, I just want to discuss some topic that doesn't fit neatly into those categories. I want to talk for just 1 minute about what you should do, because this will affect everyone sooner or later. You'll be using Guava and you'll want to request a new feature for it. And the thing that we always have to warn people about is that it's actually very hard to get new features into Guava. It is a very exclusive library that tries to keep itself as small and focused as it can. And it is even hard for us ourselves. I can't tell you how many things, ideas I've had that I think are great and I would really love to put them in Guava, but I have to convince the whole team, and I have 9 of these things just sitting in an icebox somewhere. So it's hard for everybody. If you have such an idea, we really would encourage you to file a feature request. It's always a good idea to search the closed ones first, but if you file one that's a duplicate, we're not going to yell at you. It happens. Not a big deal. And here is the secret magical guide to how to convince us that your feature is a good one. What we really need to know is, what are you trying to do? What's the best way you can do it without your feature? And then what does that code look like with your feature? We want to evaluate all these features. Again, I was mentioning this at the beginning of the talk. Our goal is to make your code look good. So if we're going to consider adding a feature, we want to see what your code looks like without it and what your code looks like with it. And if that difference is really compelling, and if we can have some believable argument that this is not just a niche, rare need, but this will actually come up for many users across the board, then that is a very compelling feature request for us. So the more that you can do to illustrate that before versus after comparison, the more likely we are to accept your feature request. But it happens that there are a number of features, because we've been doing this for several years. When you have a feature request that's new to you, the chances are relatively high that it was actually suggested once before and rejected. So don't spend too much time writing a patch before you speak to us about it first. And this is about how to help us if you want to help us, but we're kind of running out of time. So in the unlikely event anyone is interested in how you could help Guava, just ask me after class. And that's it. We have 7 minutes left for questions and answers. I have a few frequently asked questions that I will go into if no one raises their hand. And I did ask the team to come up on stage, but I didn't realize we don't actually have a handheld microphone, so there may not be any point in them coming up on stage unless someone can find such a thing. Okay, first question.
Can you tell us a bit more
Okay. So one thing is that the idea that optional of T is the new nullable T. And wherever you should have used a nullable T, now optional T is the way. That is a religious sort of argument that some people, try to make. It's not actually an argument that we make. We provide it and we say, here's some cases that we know of where it's useful. But we're not trying to present it as like, this is the way to go. I do think there are some advantages to using an optional of T instead of a nullable T, because it makes the difference clear in the code to the type system. You cannot just accidentally forget that you have to check for null, that what you have is really nullable. It's all right there, and But there are many uses for it, such as simply being able to distinguish between, I have no idea what you're asking for, and yes, I know what you're asking for, and there is no answer. For example, like, I ask you what your middle name is, and some people don't have a middle name. So you can return an object saying, I definitively know that there is no middle name, which is different from returning null, which just means I just have absolutely no idea. The data is just not there. And as pointed out, there are collections that don't support nullable elements. That's a trend as of JDK 1.4 or so. There's been a strong leaning away from allowing nullable elements in a collection, and optional lets you put that token into a collection that means definitively not present. Okay, in the blue standing. Performance cost of optional, same as any wrapper class that contains an instance. It's just a class that contains an instance. So if optional were in the JDK, then the JIT could treat it specially. That is probably true. Next question, or I will go to a FAQ. Okay, first frequently asked question. Lots of people, the first thing they ask us is, what is the difference between you and Apache Commons? Usually it really is like the first thing people want to know. What are you talking about? And so I made a tiny URL for you, tinyurl.com/Guava versus Apache, because I don't really like to answer this question myself, why I think that you should look at Guava instead of that library. But this answer was posted to Stack Overflow and it got 70-some upvotes. So I think that it is reflective of a general community consensus about the relative value of these libraries. And I think the author of that Stack Overflow answer is in this audience, not a member of our team, but I see him sitting here. It was very well done. Next question in the red.
Have you considered about faults and flat maps and all that functional stuff, and why it's used?
Why don't we have flat map? Why don't we have fold and reduce and so forth? All right, yes, I have a slide for that. Here it is in the frequently asked questions. Where are fold and reduce and so forth? And the answer is that there are libraries out there that are really trying to solve functional programming for Java. We're not one of those libraries. We added the types that we had a need for, and then we've pretty much cut it off there. We strongly believe that nothing is really going to make functional programming work nicely in Java until we finally get our JDK 8. And so we've sort of put the brakes on continuing to add more functional features.
Don't you think that with optional you have it's kind of logic to add flat map, for instance?
Because we have optional, that makes flat map
And then you have the method that gets you a set.
Yeah. Actually, I believe, now that I think about it, what you're calling flat map, we don't use the map terminology because in Java, map means Java util map. But now that I think about it, I think we are adding a method like you're asking for to fluent iterable. Like we call it transform and did we do that? So look for Guava version 13. We might have that. But in general, not a lot of more functional programming support. Next question? Yes. Did you hear that? Again? Android? I've got a slide for that too. What about Android? Okay. I wish I could say Guava is awesome on Android. We haven't spent a lot of time optimizing it for Android. So you may encounter a performance problem. If you do, we want to hear about it, and we'll try to help it. But we hope in the future we'll be able to say a lot more about having really benchmarked this stuff aggressively on Android. Guava 12 requires JDK 1.6, and it requires, if you're going to use it with Android, it requires Gingerbread or newer. If you're on Froyo or earlier, you will have to stick with Guava 11.0.2. And I think that's the universal times out symbol. So thank you very much for coming. Have a great rest of your semester.